All right, have a look at this one. So accompanied by parted is the one that you see here. Is just there is a connection between one vertex of this one to each vertex here. Okay, so let's assume that I have one vertex here. So how many vertices do I have here? 4. So it will be 4 edges. 3, 1, 3, 4, 3, 8, 3, 5. So 4 here. And if I have 4 vertex, so for each of them, 4, 4, 4, 4. So totally I will have 16 edges. Now look at here. So K2, 3 is this guy. K2, comma 3. A, B, C, D, E. So 1, 2, 3. So this one, this one, this one. How many edges do I have? 6 of them. All right. So how about the definition of this one? Complete bipartite graph is like let V be the set of the bipartition into the set V1 be a set vertices with size M. Let N V2 is the vertices N. So V1. So K N M. So it doesn't matter K2, 3, K3, 2. It's just like the same thing. Okay. So this you need to see this one. This one is just nothing new because it's just bipartite graph. The set of all edges from UV where you've got this one, then resulting is complete. So it's a very bad definition here. But complete, what I say is this one. So every vertex of here, this left-hand side should have a connection with every vertex of the right-hand side and vice versa. All right. And I believe that you can tell me just right now, what is the number of the edges of this one? How many edges do I have here? MN. Any other idea? Any other idea? How many edges do I have? MN? K2, 3. 2 times 3 is 6. KMN is also M times N. Thank you. A subgraph is the graph which is the vertices are. So let's assume that. So you got this one. And V prime, E prime. So V prime must be the G prime is the subgraph. Then V prime must be subset of V. And the edges must be subset of E. Okay. So K3 is a subgraph of K4. Yes, of course. Why? You can do that. So as a kind reminder, so I can say that this is the K3. This is the, okay, this one, this one. This is K4. Okay, so K3 is the subset of K4, obviously. An induced subgraph of a graph is another graph formed from subset of vertices of the graph. Okay, so can I do this? Okay, an induced subgraph is a graph of a graph is another graph formed from a subset of the vertices of the graph and all edges. Okay, so what is an induced subgraph? So can I take this one? Okay, so let's call this one CN C4. So can I? C4. C4 is the induced subgraph of this K4. Okay. Why? So it's not induced subgraph. Okay. So you don't You are not with me, yeah? So because what I say, you will say accept, you will accept, yeah? No, don't accept what I say, okay? Sometimes I do make a mistake, okay? So let's find this one. So I'm gonna say some example to you. K3. So why not? So you can say that. Why not? So this is the induced subgraph. So like the answer is this one. Okay. Okay, so I made a mistake. Sorry about that. I really made a mistake. Okay. So when I take induced subgraph is this one. So I will choose some of the vertices like this one. So I'm talking about this K4. Okay. So I will take the this one K4 and all of the edges connecting the pairs of the. So I will take this one. So this K3 is like really subset of K4. Okay. So it is really induced subset. Okay. Is K3 is the induced subset of the. So can I? So K3. So A, B, C, D. Okay, I got so maybe I will make a mistake. Okay, just be with me. So edges are A, B, B, C, and C, D, and D, A. Okay, A, B. So am I right? So A, B, C. So A, B, C, D. So A, B, but it's here. B, C, C, D, and D, A. So which one is problem? What's the problem?
AD.
AC.
AC is the D is the.
Okay, say so C A B. Okay.
Yeah.
B C
Yeah.
C D D A.
Yeah.
Is that right?
Yes.
Okay. So now what I think is this one. So K3 is this guy. So I choose a subset of that one. I choose this one, and this one. Okay, so then I have a pair of this one, pair of this one. But I don't have this one. So I believe that K3 is not an induced subgraph of G. Okay. Is there any question about this? Okay. See, this is K3. We want to say that this is induced subgraph. Oh, okay. Sometimes when you talk, I don't have concentration to explain. All right. This is K3. This is what I have from this guy. G. This is G. So I choose 3 of the vertices, like A, B, C. So I have to, so my induced subgraph should, it should be like this. This, if it is like this, it is the induced subgraph of this one. But K3 has got an extra edge. Okay, so K3 is not induced subgraph. Okay. All right. So now a connected, we've got just not many questions. Okay, let's finish. A connected component of a graph G is in induced subgraph of G prime with the property that G prime is connected. Okay. So it's an induced. Okay. So when it says induced, actually, so it means really connected. Okay. And adding any more vertices to that set will cause that G prime will be disconnected. Okay. So it will be really a component. A component. All right. Okay. So guys, for the last time I say that I don't have concentration if there is whispering like behind the class. All right. So let's do this one. Consider the graph with this adjacency matrix. Okay. So we've got just only 3 questions. Okay. So can I have this one A adjacency matrix? Let's remind that. What was the adjacency matrix? Okay, it is this one. Adjacency matrix is like vertices here, vertices here. Okay. So let's have this one just quickly. All right. So I have A, B, C, D. So I can just do this one here. A, B, C, D. So A to A. What? It has a loop. And A to B. Now, B to B and B to A. Okay. Not good. C, D, and D, C. Okay. So what I see is this one. The graph with the adjacency matrix. How many connected components in this graph you can see? Then I will see that just 2. Just this part and this part. So I can get these 2. A, B, C, D. Okay, so one component, one component. Now, if I add any, so what's the component? If I add any vertex to that, that will be like, it's not possible. So this will be, if I add this any, okay, it's not. There is in the original one, there is not an edge, something like this. So this one is really like one independent component, and this one is really another independent component, connected one. Okay, so now have this one. Okay, for more explanation, we will talk about this one in the workshop. Okay, now this one, a bridge. This is the last slide. All right. A bridge is an edge in the graph such that if we remove it, the graph will be disconnected. So somehow it's like obvious. A cut vertex is like the something like maybe this one. Okay, a cut vertex or a city is a vertex in a graph such that if we remove it, the graph will be disconnected. Okay, so do I need to do that? Yes, let's do that. A, B, so A, B, A, C, A, C, A, D. All right. So, all right. So all of the edges and all of the vertices are breached. All of the edges are breached, and all of the vertices, if I remove one of that, then we will have disconnected graph. Okay. But let's say that what about like this one is edge, 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 this one 3 edge. So I have 3 bridges. Now, what I said, it was like just not right. Okay. And you should have a comment for me. Now, if I remove this one, B, so then it will be A, D, C. So the incident edge will be removed. If I remove this one, the road will be useless. So this edge, I will remove it. Then it will be like this. So it is still connected. So the root, this is a graph which is 3. Okay, have you heard about 3 decision theory? So you will study in the upcoming years. Okay, in machine learning. So A, this is a root. These are the leaf. 1 leaf, 2nd leaf, 3rd leaf. So these are the leaves. So if I remove this one, this incident edge will be removed. So it will be just A, B, A, C. And similarly, it can happen to D, C. So only A is the cut vertex. The leaves are not cut vertex. All right, so a direct graph which is the same graph, but it has a direction between the edges. So at this graph, AB, the edge AB is not equal to the edge BA. Okay, so let's remove this one. Now, here is the thing. Now, the last question. Now, we see that this one, so A, B, C, A goes to B. So, and also look at this one. Instead of bracelets, we show it by round bracket or parentheses. So it will be ordered. So the order is important. Okay. So AB, BC, and CA. This will be the graph of this part A.
In this order, we have to keep in mind.
Say again.
So what you said that we have to keep in mind that order.
Yeah, ordered. So from A to B. From A to B. So the direction is from A to B. So from B to A, it won't be right. So it is possible. So can I write the incident adjacency matrix is this one. A, B, C, A, B, C. So okay, A to A, 0, A to B, 1, A to C, 1, B to A. Huh? Yeah, A to C is 0. Yeah, B to B, 0, B to C, 1, C to A, 1. This one is 0, 0. Okay? All right. So part A, part B. Part C. So let's do this one. A to goes to inside to itself. What? AB, AC. Okay, so the incident matrix, I don't want to write the labels. A to A to B, A to C, and so 0, yeah. Okay. Okay, so these are the questions that I chose for you, but I saw that I could possibly like say about the Hamiltonian graphs, Euler path, some cycles, but I saw that today you didn't study them, so I choose not to touch them. Okay, so let's stop the recording.